Over the past 6 weeks, I've run the Anycubic Kobra S1 Combo for more than 1,000 hours, printing nonstop through murals, organizers, and multicolor models. It pushed over 27 kilograms of filament with more than 90% uptime, but under that kind of pressure, things started to break. This isn't just a long-term review, this is what early reviews got wrong, the quirks that show up after weeks of real use, the problems that tuning can't fix, and the surprising things this printer actually gets right. If you're thinking about buying the Kobra S1 Combo or wondering if it's improved since launch, this is everything you need to know. To start with, anyone considering a new 3D printer, ease of deployment is a big deal. The days of spending hours bolting parts together, tramming print heads, and manually leveling beds are mostly behind us, and the Kobra S1 Combo does a solid job embracing that reality. Out of the box, it's nearly fully assembled. The Ace Pro multi-material unit is packed inside the printer's main body. Just remove a couple of screws, and lift it out and set it aside. A few more clearly marked screws releases the internal transport brace, and another couple free the build plate. Cut a plastic strap, peel some protective film. That's pretty much it. The printer is physically ready to go. Installing the Ace Pro is just as straightforward. Mount the filament hub, plug in the labeled cables, and connect the PTFE tube to the selector unit. The only quirk here is that the printer and the Ace Pro each require their own power source. That means 2 cords, 2 switches, and a bit more outlet space on your bench. On first boot, the S1 walks you through a quick setup, language, region, Wi-Fi connection. You'll get the option to bind the printer to your Anycubic account, but I skipped that. LAN mode works just fine and gives you full local control. The printer then runs a full set of self-checks and automatic calibrations, which buys you a couple of minutes to get the software installed. I grabbed Anycubic Slicer next, added the Kobra S1 profile. Loading material into the Ace Pro was surprisingly smooth. I started with 4 rolls of Anycubic PLA, dropped the spool into the hub, and manually fed each one into its slot. The system grabbed the filament, automatically loaded it, and even detected material type and color via the RFID tags. If you're using third-party filament, you can manually assign these values. Still quick, still easy. At that point, the machine was ready to print, and as usual, I skipped the test benches and calibration prints. Instead, I sliced up a pair of multicolor baby dragons because if it can nail that right out of the gate, we're off to a good start. I left all the default material and print settings intact except for cutting the purge volumes in half. In my experience, the defaults are overkill and waste a ton of filament. The slice job sent over LAN without issues. And 25 hours later, I had 2 solid looking dragons. The yellow filament showed some stringing, but considering I'm printing at 7,000 feet of an elevation with around 12% relative humidity, that's pretty typical for me. The surface quality was great, overhangs printed clean, and there was no visible color bleed even with the reduced purging. After a test like that, I was confident enough to move into full production. Over the 6-week test, I put the Kobra S1 to work in my main workshop, a controlled environment designed for long-term hardware testing, stable temps, filtered airflow, and multiple machines running side by side. I wasn't just running a few test prints for B-roll. I used this printer like a production tool, day and night, logging more than 1,000 operational hours with over 915 of those actively printing. That gave me a consistent over 90% uptime, excluding scheduled maintenance and the occasional delay waiting on me to swap plates. I ran nearly 30 kilograms of filament through this machine, mostly PLA and PETG from various brands. No exotic blends, just what most people would realistically use on a sub $500 printer. Every new spool was dialed in with basic calibration, temp towers, flow test, and pressure advanced tuning, just enough to ensure precision and consistency across the entire print run. The biggest workload came from a series of paragami wall murals. Each one consists of 450 interlocking geometric cubes printed across 25 separate build plates, requiring about 230 hours and 6.7 kilograms of filament per mural. I printed 3 sets. One is mostly glued up, the other 2 still boxed up, so that's That's over 1,300 parts meant to align across dozens of separate jobs. A perfect stress test for consistency and mechanical stability. Then came a multi-board modular wall organizer. I used a stacked tile approach, 9 PLA tiles per job separated with PETG inner layers for easy separation. Each stack took 34 hours and about 1.5 kilograms of filament. I ran multiple stacks and added trays, bin hooks, and accessories, totaling over 200 additional print hours. Altogether, this wasn't about printing toys or calibration cubes. This was real work, tight tolerance, multi-part, practical assemblies, and under that kind of load, things start to crack. The question is, how bad did it get? Now, overall, the Kobra S1 held up okay. For a printer in the sub $500 price class, it maintained mostly consistent output and dimensional repeatability across a ton of print time and material throughput, but that doesn't mean it was flawless. While many failures are typically user-induced, things like missed support settings or slicing errors, what I ran into were a handful of hardware-related issues that had nothing to do with tuning or technique. Based on my logs, the printer experienced about a 0.27 hardware-related failures per kilogram, or one failure every 3.36 kilograms of filament, which worked out to a mean time between failures of just under 6 days. That's not terrible for a budget machine, but the frustrating part is why those failures happened. They weren't due to worn parts or neglect or user error. They were due to system bugs, firmware hang-ups, error handling glitches, and screen freezes that led to full print loss. These aren't problems you can fix with calibration or maintenance. They're bugs in the printer's firmware and logic, and unless Anycubic pushes updates, they're going to keep happening. We'll get into the specific failure modes in a bit, but right now, this is where most creators cut to a sponsor break, but not here. I'm not even trying to sell you this printer, let alone any other random product you didn't come here for. This review isn't based on a press kit review guide or a few days of casual testing. I actually used this hardware hard for nearly 2 months. No shortcuts, no scripts from marketing, just real world use, deep dives, and honest results. This channel isn't monetized yet, and there are no sponsors providing the $400 of filament I burned through for this video. It's 100% audience funded, so if you value long-term real use reviews over flashy unboxing and spec retails, do me a favor, hit that subscribe and stick around. That's what helps me keep doing this the right way. So now, uptime and throughput is great, but it doesn't mean much if your parts aren't usable. Precision matters, especially when you're assembling hundreds of printed components into large-scale projects. So before diving into these massive mosaic runs, I took the time to properly calibrate each filament to the printer in my environment. That meant running temp towers, retraction towers, pressure advanced flow rate, and max volumetric flow calibrations. I wasn't looking for absolute perfection. I was aiming for repeatability and consistency across the board, because if each of these paragami blocks came out even a quarter millimeter too narrow or wide, that deviation would stack up fast. Over a 1,200 millimeter span, or nearly 4 feet, you'd end up with the final blocks that no longer fit the mounting board. Proper calibration didn't just help with fit, it also let me push the printer to its realistic speed limits without sacrificing quality. Anycubic advertises speeds up to 600 millimeters per second with a recommended max of 300 millimeters per second, but that's marketing math. For example, with Anycubic's own rapid PLA, I found that the 0.4 millimeter nozzle and 0.2 millimeter layer heights and a flow ratio of 0.96, the actual volumetric flow ceiling came in around 19 cubic millimeters per second. That capped my usable print speed at 228 millimeters per second, so I set infill speeds to 20 with perimeters around 180 and kept things stable from there. To avoid sanding and post-processing every single one of these blocks, I printed them upside down, top-facing surface laid flat on the build plate. That gave me a smooth, consistent finish right where it would be visible, but it also made the print trickier. Many blocks have steep overhangs and very little surface area for bed adhesion, so I had to use brims and supports to keep things locked down. The downside is the underside, what now mounts to the backer board, wasn't as precise. Unfortunately, the Kobra S1 showed some inconsistencies here. Despite my tuning, the bottom dimensions of the blocks would drift by up to plus or minus 0.35 millimeters. That's enough to cause significant misalignment over long rows of blocks. The human brain is great at detecting patterns and even better at seeing a problem in one. I compensated by randomly rotating each block along the X and Y axes before printing. That distributed the error more evenly, and in the end, all 450 blocks fit well enough to be used without major adjustments. However, I did notice a gradual decline in surface quality and dimensional accuracy over time. Early on, the X and Y surfaces of my blocks were smooth and consistent, but as I approached the 100-hour mark, I started seeing subtle drifting on the X-axis, visible as layer shifts and slight sizing errors. At first, I suspected belt tension, but everything checked out. The self-tensioning mechanism was keeping the belts firm. The only thing that made a noticeable difference was running resonance compensation every second or third print, roughly once every 24 hours. Not ideal since it added time to the workflow, and in my case, it literally broke the printer. Right after starting a print with resonance shaping enabled, I found a random screw just sitting on the build plate. At first, I thought it maybe had fallen off the shelf, but no, during routine maintenance, I realized that it actually come from inside the print head. One of the two screws holding the fan into the print head cover broken off. Now I've got a fan barely hanging on with a single screw, and honestly, I don't have a ton of faith that one's staying put either. So yeah, resonance compensation technically helped print quality, but it also shook my printer apart. As for the multi-board tiles, clips, and accessories, they printed beautifully. The generous built-in tolerances gave them a lot more room to breathe. That said, I did run into some corner lifting on the larger stacked tile prints. It happened right up front where the part caught a draft. Even though it's PLA, that much mass in a dense print will still shrink and warp with temperature fluctuations. To fix it, I simply closed the door, resulting in flat prints with no other problems. Overall, with careful tuning and a few workarounds, the Kobra S1 did deliver large, repeatable assemblies, but there are some frustrating quirks you want to be aware of if you're printing at this scale. Of course, if you want any printer to stay reliable over hundreds of hours, it needs regular care. Thankfully, the Kobra S1 didn't demand much. About every 200 hours, I take 15 minutes to wipe down the rods and lead screws and relube them. Wash the build plate with soap and water, and then rerun pressure advance tests to check for nozzle wear. The belts are self-tensioning, and while there is a way to adjust them manually if the tensioners drift, I never had to, not even after nearly 1,000 print hours. That kind of upkeep helps prevent binding or sudden layer shifts, but it won't save you from all the failures I ran into. The first failure was a classic, a filament spool tangle. If you printed more than a week, you've probably had one. Not the printer's fault. In fact, the S1 did detect the jam, paused the job, and issued a warning. But apparently there's a timeout built into that warning, and I wasn't home at the time to clear it, so the printer eventually gave up and failed the job. If I had responded in time, I could have fixed the tangle and resumed the print without issue, but once it hits that unknown time limit, recovery isn't possible. Most frustrating were the screen freezes. This happened several times, usually when the screen was asleep and the printer sent me an error on the mobile app, most often a clogging alert, except there were never actual clogs. Anyway, the printer would pause, the screen would stay black, and when I tried to wake it, nothing would respond. Sometimes after tapping the screen repeatedly in frustration, it would suddenly wake up, causing an accidental tap of a button in the process. Slowing down the footage here, you'll see that the screen spontaneously wakes up and I accidentally dismissed the error, which resumes the print even though I hadn't resolved anything. Worse, on 2 occasions, I hit the stop button by mistake, which instantly killed the job. No confirmation prompt, no way back. When the screen wouldn't wake up at all, the only fix was the IT classic: turn it off and back on again. That would reset the screen and trigger the power loss resume feature, which I discovered doesn't work properly. Both times I tried it, the resume print completely misaligned. You can see here where the perimeter walls are being laid down way inside the infill pattern, and I had no idea how to recover that, so I had to scrap the job. The second time, power loss resume appeared to work until I inspected the final print. The layers had shifted enough to ruin the fit, and that's a fail in my book. Per customer support, I did try reflashing the firmware twice, but the screen freeze problems persist. Another issue was a failure to load error from the Ace Pro. It just kept cycling through all 4 spools trying to reload filament, but never succeeded. After disassembling it, I found a tiny piece of filament jammed in the filament hub right next to the detection sensor. It wasn't visible until I took it apart. A reoccurring problem was another tangle, but not the typical kind. This was due to the Ace Pro's design. It mostly happens with tightly wound cardboard spools. Once filament drops below about 100 grams, the angle feeding into the Ace becomes too steep. There's just not enough torque for the extruder to pull the filament and rotate the spool. You can catch this if you're nearby and swap the spool in time, but again, that mystery timer is ticking in the background, and I lost a 12-hour job this way. There are some community-created spool adapters that may help with this. I'll need to try those out. Then there was one final random failure. I walked in to find the printer moving normally, but well above the part. The hot end was ghost printing a job several millimeters above the model, and no filament was extruding or even moving through the PTFE tubes. I suspect the filament snapped near the Ace unit, but there are at least 2 sensors that should have caught that and paused the job. Neither did. All things considered, most failures weren't consistent, but they were frustrating when they happened, especially considering, for the most part, they were tied to firmware behavior rather than mechanical faults. That's the kind of thing I hope Anycubic continues to refine in future updates, because honestly, after the final screen freeze and resume failure killed an 8-hour print job, I just finished that last plate on another, more reliable printer. Now that we've covered what went wrong, let's talk about what's improved, because to Anycubic's credit, the Kobra S1 Combo is a better machine today than it was when it launched. Early reviews all seem to land on the same conclusion: solid hardware, frustrating software. That was my expectation. In fact, before even unboxing the printer, I'd already planned to flash it with wrinkles, a community firmware mod that adds fluid full vanilla Orca slicer compatibility and even SSH access. But after a few prints with the stock setup, I changed my mind. The current implementation of Anycubic Slicer Next, which is a custom Orca fork, turned out to be completely usable and surprisingly polished. The interface is intuitive, material profiles are flexible, and advanced controls like purge tuning are right where you would expect. I used default settings for the first multicolor print, only reducing purge volume, and it worked flawlessly. One of the biggest complaints from early users was the AI failure detection, consistently throwing false alerts and pausing prints unnecessarily. That's apparently been addressed. Now you can individually toggle each AI tool, adjust the sensitivity, and decide whether errors just notify or actually pause the job. I used medium sensitivity for the entire 900 plus hours and didn't get a single false positive. I also didn't get any true positive, but that's likely because I never had a traditional failure, no spaghetti, no collapse supports, nothing for it to catch. Even the one air print I had didn't register because the system didn't detect any extrusion. It's not perfect, but it's better. There have also been small but meaningful improvements to the Ace Pro multi-material unit. The automatic spool switch feature now works exactly as it should. As long as you've got another spool loaded with the same material and color, it'll switch seamlessly when the first one runs out. That's part of what made this project possible. I was able to chew through the tail ends of a whole bunch of old rolls I had on hand during the Perigami mural prints without babysitting the system. You can also run the filament drying function while printing, which is a nice time saver. That said, how effective it is, I'm not sure. Shout out to Ross, aka Fohammer, who pointed out to me that the Ace Pro doesn't have a proper exhaust ventilation, so all that warm, moist air just recirculates inside the chamber. When the cycle ends, that moisture likely just reabsorbs into the filament. I couldn't really test this myself. My climate is way too dry, so humidity just isn't an issue, but it's worth being aware of. Beyond that, connectivity and mobile app remote management have been flawless. I switched over to cloud mode after the first print and monitored everything remotely for the rest of my testing. The camera feed isn't high res, but it is enough to spot layer issues or misalignments, and the mobile app gives you full control. You can pause, resume, even exclude components live from the build. You can also do this from the touchscreen, and I use that twice during the test. Once to skip a block I accidentally flipped upside down in the slicer, and once when I spotted a bad first layer. Turns out I had a spot of stray lube on the build plate, but it saved both of those prints. So overall, Anycubic has made real progress since launch. The printer slicer is friendlier, the AI tools are more configurable, the Ace Pro features are better integrated. It's still not perfect, but the experience now is miles ahead what most early reviewers had to deal with. and that's worth recognizing. Now, before I wrap this up, let's talk about what it actually costs to run the Kobra S1 Combo. Over the 6 weeks of continuous testing, I tracked both power usage and material waste to get a realistic picture of long-term operating costs. On average, the printer consumed about 4.5 kilowatt hours for every 24 hours of active printing. That added up to 170 kilowatt hours across my entire testing period. Based on my local power rates, that came out to about $25 in electricity. As for material loss, print failures totaled just over 1.5 kilograms of wasted filaments. That's roughly $20 worth of plastic. Maintenance costs were barely worth counting. I went through a rag and maybe $1 worth of PTFE lube. Let's call it $2 total. Put it all together, and the cost of operation came out to about $1.17 per kilogram of successfully printed material. That's a pretty efficient number, but it could have been much better without the bug-related failures. Now let's talk about noise. Measured 1 meter from the printer, average noise levels were around 66.4 dBA, with occasional peaks hitting 70 decibels during faster travel moves. Thanks to the solid door and treated walls of my workspace, that dropped to a comfortable 41 dBA in the adjacent room. So while it's not whisper quiet, the Kobra S1 Combo isn't disruptive either, especially if you've got a dedicated workspace. So after 6 weeks of nonstop use, it's clear the Kobra S1 Combo has matured since launch. A lot of the early rough edges, especially on the software side, have been smoothed out. The slicer is more user-friendly, the multicolor workflow is reliable, and features like automatic spool switching and remote print management worked exactly the way you'd hope. Print quality is solid right out of the box, the hardware is capable, and the improvements to the firmware, especially configurable AI alerts, purge tuning, and spool swaps, make it a far more usable machine today than it was when reviews first dropped. But as you've seen, there are still bugs lurking in the system. Screen freezes, inconsistent error handling, and resume failures weren't just one-offs, they were reoccurring enough to be part of the experience. And that's the frustrating part. These aren't tuning issues, they're not something you can fix with better calibration or more printing experience. They're baked into the firmware and the logic of how the machine responds when something goes wrong. And until Anycubic updates that behavior, these failures are just part of the deal. That said, price matters, and at $459 retail, often lower during sales, the Kobra S1 Combo undercuts other comparable multi-material systems by a wide margin. It comes in $100 to $200 cheaper than options like the Bamboo Labs P1S, the Creality K2 Combo, or the Cheetah Q2. If you're on a budget and willing to accept a few workarounds, the Kobra S1 Combo is a powerful tool with real output potential. For small shop production, classroom use, or hobbyists, it offers an impressive set of features for the money. But if those other printers drop into the same price range, and they sometimes do, it's hard to recommend the S1 Combo over the more polished experience of something like the P1S or the slightly larger K2. Until Anycubic addresses these lingering bugs, the Kobra S1 remains a strong value pick, not the obvious winner. That's it for this one, guys. Let me know what you think in the comments, especially if you've been running a Kobra S1 yourself. I'll pin any firmware or feature updates there as they roll out. Thanks for watching, and I'll see you in the next one.